the same, but this is a difference of x and 1, so it's a plus b, a minus b. So we had to take the difference of squares twice.
But only
That's
on the
hard.
one that's negative. That's got the
Only when it's a difference. Only when it's like this one. The trinomials are just plugging in the formula, right? But the binomials, you have to figure out a way to rewrite it. Okay. Any other questions for right now?
We have a field trip outside.
I'm confused with the slope method,
Okay.
because if you look at like the difference of two cubes, it's like a minus b, and then it's not same, opposite.
Yeah,
always
it's saying
opposite.
starting here, your sign is the same as this. Same, opposite, always positive. Does that make more sense?
Yeah.
Okay. I might consider that.
Yeah, because I really don't have those.
I will. You won't have them for your test, but I will put them up there for the quiz. That's fine. Because I'm more concerned with you knowing how to use them right now than memorizing them. So it's not. Yeah. Elizabeth, no. Okay. All right. So let's take the quiz first, and then we'll go over the one from last time.
You're doing great. Over there.
What am I doing?
No, you're just, you know what you're doing.
Oh.
Like, when we did the thing,
She's complimenting
you
me.
came up and you're like, Daddy. I'm just
Oh,
jealous, okay?
I was like, what am I doing?
Her green movie's coming out.
You're blowing a curb. Cut it out.
Do we even have a curve in here?
No.
But if we did, no.
My first test.
I do. Let's just say this last quiz, I don't think it was this good.
Okay.
I'll write those formulas on the board for you.
few more minutes because we really need to go over your stuff.
come in. I know you guys didn't get done. Obviously, that was too many questions. I will consider taking one, maybe two off, you know, not for grading since it wasn't there enough time. I'll make sure we get started as well.
So loud that she's like, come on guys. I'm like,
I didn't finish 2 of the squaring ones.
All right, we will go over this on Tuesday when we have our review day, because our test is a week from today. So I'll grade those and get them back to you. Let me hand out the quiz from last time and we'll go over it.
same. Just negative, yeah.
Same.
I'm proud of myself. Let me tell you, the only people this grade affected were, in other words, replaced like another score. I'm not going to say your grade, I'll just say who's got changed. Carolyn, Sarah, Keely, Evelyn, Renee, Shannon, and Roxy. So if I called your name, this grade went down as one of your top quiz grades. If I didn't, then it didn't count. If that makes you feel better or worse. Okay, so would you like me to go over every question, or do you just want to ask me the ones you need help with? Go over all of them? Okay, we're going to go over all of them because some people need us to go over all of them. Okay, number 1. Factor out the GCF from this expression. What's the GCF here? 5x plus 1. And what do you have left? 7x plus 1. That was the answer.
Oh, I thought you just had to tell what the GCF
Me
was.
too.
That was.
Well, it says to factor. Factor the GCF from the expression.
I put both down because
I can see how you thought that, but when it says factor, make sure you're factoring it out.
Okay.
You know what, if you do the study plan online in the math lab, it really tests you because you have to read the questions, and because it gets tricky, but it really helps you remember during the test.
Yeah, Shannon's used the study plan in math lab, and she said it's very helpful. So, just an FYI, if anybody wants to look at that in there.
I know it's extra work, but it's worth it if you get it. It helps you get it. So.
Do you use my math lab in 099 too?
Yes, every math at this school will use it.
Seriously, even in like statistics and math? Or just in
You know, when you get into the higher level math, I'm not sure. I know for college prep. I don't know what happens after you leave like 103.
yeah, once you're out. Side test, calculus, and
I'm pretty sure they all do, but I only teach college prep, so that's all I'm
you
doing.
don't, oh, you don't teach in college?
No. I don't have a Okay, factor by grouping. What can I take out of this?
Nothing.
In the first 2 terms, because this is 4 terms, so we're factoring by grouping. Take a 3x out, and you're left with x plus 4. What do I take out of the second two?
1.
Just a 1 because it already is our x plus 4. Now what's our GCF? X plus 4, and I'm left with 3x plus 1. Number 3. Factor the GCF from each term in the expression. What's the GCF of this one? 5y cubed. Y cubed is the most y's I can take out. I'm left with 8y to the 10th minus 1. This is one of those tricky ones again. 5y cubed matches this. We're taking all of it out, but that doesn't mean it drops off or disappears. It just becomes 1. So you have to make sure you put the minus 1 there. Number 4. This verbiage was confusing, but I think I said during the quiz, just to factor it every week. Okay, so from the first two terms, what can I take out? A b. And I'm left with n plus 7. What can I take out of the second two groupings? Not just an a, but a negative a. Because I want this to be an m plus 7. When you're factoring by grouping, you want these two to match. So you've got to look at your sign right here to make sure you're taking out the positive or negative that will term this positive. Does that make sense? I did have some people miss this because of signs. So my final factoring is b minus a m plus 7. Number 5.
Plus or minus? The question is the minus.
This one? Yeah. It should be b minus a m plus 7. And I think maybe if you missed the sign, it was because of this. Here we're also factoring by grouping. What can I take out of the first two? Z. And I'm left with z minus b. What can I take out of the second two? What kind of a? Negative a, because look, I want this to be negative. So I'm picking out a negative a, therefore turning that into a positive z and a negative b. So what do I have left? Z minus a and z minus b. Questions so far? Yeah, this one and that one are tricky in that you had to make sure you pulled out the negative a. So make sure your signs match when you're grouping. Number 6, 7x to the 4th minus 21x cubed plus 35x squared. What's my GCF? 7x squared. Okay, so I have x squared left, a negative 3x, and a plus 5. Am I done factoring? Yes. How would I know that? Okay, good. You'd still want to look at this. You want to see if you could factor it. And when you came over the side, you say, is there something times something that gives me 5 and add to give me negative 3? And there's not. Therefore, this trinomial is prime and you're done factoring. But that's something you would want to check for. All right, number 7. Again, we have 4 terms. We're going to factor by grouping. The first two, what can I take out? X. I'm left with x plus 6y. The second grouping, what can I take out? I need to take out a negative 7y. So that this becomes a positive x and a positive 6y. When I pull out my GCF, I'm left with x minus 7y and x plus 6y. Number 8. I don't
understand. What do you think on the negative 7y and it's going to be a negative 6? Because there's a negative 7 somewhere.
If you're think of when you're pulling out this negative 7y, you're really dividing each term. So negative 7xy divided by negative 7y, these cancel to be positive. When I'm dividing this negative by negative 7y, it becomes positive. Does that help you see it at all? Because when you're taking out, you're dividing this by each term, and a negative over a negative becomes the positive. No?
No, because I'm pulling the number down, so I'm pulling down and whatever sign was sitting in front of it.
Which one?
I'm not change this, I change both sides.
This is the 4x.
So, I'm not thinking of it as dividing by 8.
But when you say pulling it down, what are you pulling down? This?
I'm pulling out the negative 7 from the negative 7xy.
Okay.
And I'm pulling out negative 6 from negative 42y squared.
You're pulling out negative 7 from this. You're not pulling out the 6. You're pulling out a negative 7. So when you take out the negative 7, you're taking the negative with it. Okay. And do look at it another way is you are dividing each term. That's what you're doing when you're taking out this GCF, you're dividing. So maybe that will help you with your sign. Okay, let's look at this next one. We're factoring by grouping again. What can I take out of the first two? 4x squared. So I'm left with 2x plus 3. What am I taking out here? Negative x. Why negative? Because I want this to be positive. So I need to change the sign, therefore I'm taking out the negative. So I have 2x plus 3. When I regroup this, I get 4x squared minus x, 2x plus 3. Am I done? No.
No,
That's where I messed up there.
That's where I messed up too, because I didn't know where to put it. I
Well,
knew that it wasn't complete factor.
It's not complete, so you can take another GCF out of here. I can
X.
take out another x, and I have 4x minus 1, 2x plus 3. You're not always necessarily done at this point. You got to make sure everything is still factored out.
Tricky.
Yeah, it is. Okay, number 9. 7x cubed y plus 5xy squared plus 4xy. This time I have a trinomial, so I'm not factoring by grouping, but I do take out a GCF. And what is it? An x and a y. So this is divided by xy, and I'm left with x squared, 7x squared. Yes?
Could we go back to number 8 for just a second?
Yeah, just a second. Okay.
Why wouldn't you start by taking out the greatest common factor, which is x?
That would be fine to do. And then you wouldn't have had to do this at the end. You can bring it with you. I didn't see that, and there's nothing wrong with doing it. That's actually the first thing you should have done. Because you should look for a GCF first. But the good thing about making this mistake is to show you it can still come out at the end if you don't see it. But ideally, she's right. We should have said, is there a GCF? And we should have taken it out and then proceeded. You end up the same place. You're just doing it early instead of late. Good call, Shane. Okay, number 9, am I done here?
Yes.
Yes, but would I want to check? So, is there anything that multiplies to be 28 and adds to be 5? We can't think of any. It's prime, so we're done. Okay, last one, number 10. 12t squared minus 8t minus 3t plus 2. There's 4 terms, so I'm going to factor by grouping. What comes out of the first 2? 4t. And I'm left with 3t minus 2. This looks like what I want, but what has to happen? I have to change the signs. I do that by taking out a negative 1, making this a positive 3t, and then a negative 2. So now when I take out the GCF of 3t minus 2, I'm left with 4t minus 1, 3t minus 2. Questions? Do you think you would have done this better now than you did quiz day?
I think I would have done better if I had a little more time.
A little more time on it, yes.
Could you switch the two internal to student problems?
On this one?
Yes.
Yes, you definitely could.
That's what I did.
Yep.
I didn't need to.
You did get the same answer? If you want me to try it that way, sure, let's try it. You should get the same answer. You switch the row terms. So she rewrote it minus 3t minus 8t plus 2. So the first two terms I would take out a 3t and I get a 4t minus 1. And here I would take out a negative 2 and I have 4t minus 1. So I end up with 3t minus 2 and 4t minus 1.
It's because I drew the negative sign from the finger.
Okay. But it should work to flip those. It should still come the same.
Yeah, that's the one I got
All right.
I'm looking at 10 and I'm still a little confused.
Okay. This way, or did you switch the terms?
Oh no, because I was thinking that the 4t was a greatest common factor. Sorry, I was looking at it wrong.
That's okay. All right, so let's learn our next two sections. You need to do a lot of work over the weekend, because although your test is until next Thursday, there's a lot in this chapter. So please work on your homework and catch up, so on review day you can ask good questions and you'll know what to do in the review. Also on review day, I've got a factor guideline sheet that I will make copies for you. It's also in Math Lab, Shannon tells me. What's it under? Documents?
It's not lecture notes. It's where you would get the lecture notes. There's a separate area just for that.
Okay. So apparently this is in Math Lab Plus also, under lecture notes. It's just factoring guidelines, and it kind of summarizes everything we've learned on a couple sheets. You know, when you do which kind of factor. So it'll be a good study sheet. All right. Done. 5-6. The good news is 5-6. We're not really learning anything new. We're just adding on. So what we're going to do is take our factoring and use it to solve quadratic equations. It's kind of the whole point of why we learn factoring. Because in the real world, you asked me when you're going to use this, there's real world questions that you have equations for and you have to know to solve. And the only way to solve quadratic equations, not the only way, but one way is with factoring. Another way is with graphing, you'll learn in 099. Okay, what is a quadratic equation? A quadratic equation looks like the trinomial we've been factoring. But what does the word equation mean? An equal sign, so it equals 0. That is a quadratic equation. A cannot be 0. That's just a given. So it's going to take this form of a trinomial starting with degree 2, and it has to be set equal to 0. Examples of quadratic equations might look like this, might look like this, or might look like this. Actually, it could even look like that. As long as it has a second degree, it doesn't have to be a trinomial. It can be a monomial or a binomial. But it has to have degree 2, and it has to be set equal to 0. That's a quadratic equation. Okay, that being said, we're going to use something called the zero factor property to solve these equations. And all it says is if A times B is 0, then either A is 0 or B is 0. That's just a fact, right? If something equals 0, one of these had to be 0 for that to happen. So with that knowledge, let's look at a factored
Wait,
trinomial. Yes, ma'am.
you just said A cannot be 0, so therefore can it only be...
In that standard form,
Okay,
not
just
for the
double-
0 property.
Not, this is two separate.
Well, this is saying why, when something's set equal to 0, something had to be 0.
Except in that
This A
equation.
is not that A. Here, let's do this. Let's use different letters.
So A can be 0 in one, but it cannot be in another, and we need to figure it out.
That A is not this A in my example.
So just the first one.
Keely, that A is not this A. So I just changed it. So it's something completely different and won't confuse you. Okay? Do you understand what this is saying? Is what's important. If you have two numbers multiplied together,
Yeah, no, I understand
one
that.
of them has to be 0.
Right, I understand that, but
Yeah.
just over here, it
That's
can't be the
separate from
first.
this. That's separate from this.
Okay.
So using A is what confused you, so I'm just going to change it.
So in these equations, A is not legally there.
Right.
The A next to the X squared.
Right.
Because A substitutes a number 7,
And
5.
Here's why A can't be 0. What did I tell you a quadratic equation has to have?
It equals,
A degree of 2.
oh,
If A is 0, this knocks this out. And then I just have bx plus c. That's not a quadratic equation. That's the only reason A can't be 0, because you have to have a second degree term.
So you feel like if B and C, if B times C equals 0, then B or C
Sure.
has to be 0.
Yep. What's written over there was separate from this. The letters don't really matter. I could use W and Z. It's just to tell you if two things are multiplied, one of them had to be 0 for different reasons. Does that make sense? Okay. And the only reason that one says no 0 is we have to have that second degree term, or it's not a quadratic. Okay. I love it. You guys keep me on my toes. Okay, let's look at this quadratic. If I factor this, I'm looking for two things that multiply to give me 16 and add to give me 10. What would that be? 8 and 2. Right? Okay, 8 and 2. Now, if this has to equal 0, using this property, I'm saying either this term is 0 or this term is 0. Right? In order for that to be true. So in this, x would have to be negative 8 if I solved for x. And if I solve for x here, it'd be negative 2. These are two possible solutions to this quadratic equation. X could be negative 8 or x could be negative 2.
But
For that
X
to
would be the
true.
same in both.
I'm sorry?
But X would be the same in both of those. So if you solved,
yes.
okay.
So what do you say?
What am I saying?
I'm quadratic incorrect.
Okay. You're with me here together.
Now we know what X can be. It
So
can
it's either
either
one
be,
of those.
it can be either a negative 8 or a negative 2.
Yes, you're solving this quadratic equation, and you're saying for this to be true, x could be negative 8, or x could be negative 2. Because plug them back in. If I plugged these in, I would get 0. Those are two possible solutions for this equation. Does that make sense, Melissa? That they're the two possible solutions to make this 0?
Yeah.
And this is just how we find those. Instead of plugging in random numbers to see what gives me 0, I use factoring to find out what those would be.
Okay, so x plus 8 and x plus 2 are not negative.
No.
The negative numbers are negative.
Yes. That's what makes this different than what you just did. What you did before was expressions. There was nothing over here. You were just factoring. Now they're asking you to use your factoring to solve an equation.
So you wouldn't know, you just give two answers.
Your answer is x is negative 8 or x is negative 2.
So you just do as long as there's two pluses, you just do the inverse?
Yeah, because you're solving this equation just like you're used to. How would I get x by itself? I subtract 8 from both sides.
Okay.
What if it said, Carolyn, like this? Then what would x be? 4. So all you're doing is solving for x. In this case, it just so happened it was the inverse of those, but it's not always.
It's not always the opposite of what I was saying.
No, it's not always the opposite. You solve for x. So if it looked like that, x would be 4.
No, I mean for the zero. With the zero on the end. It's not always the opposite of the signs. that
No.
you've given them the answer.
No, not always. If it looks just like this, then yes. If it's just x and a number, it's the opposite signs. If there's a number in front of here, like say 2, then it wouldn't, because you're solving 2x plus 8 equals 0. 2x equals negative 8. X equals negative 4. Right? So yes, it is the opposite sign when it just looks like this, but if there was another number in there, it would not be. So don't even remember it that way. Just remember it that you're solving for x.
I have questions about
That you're solving for x. Yes. To check yourself. Negative 8 is 64 minus 80 plus 16. 64 and 16 is 80. 80 minus 80 is 0. So, and then if you put negative 2 in, you get 4 minus 20 plus 16, which equals 0. So they should work, and that's something you should check on your test. Whatever answers you get here should be able to plug in. We're going to do a lot more, guys, a lot more. That's just the first look at it. Okay, so let's look at, I'm skipping the factoring part for right now. Let's assume I've already factored. This is what I got. Okay, I've already factored my trinomial. These are the two factors I get, and they're set equal to 0. So how do I solve this? I set each one equal to 0, because I know either that's going to be 0 or that's going to be 0. Does that make sense? Now I have to solve for x. So 2x equals negative 5, x equals negative 5 halves, or 3x equals 7, x equals 7 thirds. So my answer for this problem was negative 5 halves or positive 7 thirds.
So all we do is we factor like we normally would.
Yep, set
And then
equals
you
0.
set each factor equal to 0.
Solve for it.
Yeah.
So it's kind of what you've already done. This is just an additional step for solving equations. Setting them equal to 0. Okay, so here are the steps we're going to use. Solving quadratic equations using factoring. The first step is just to make sure you write the equation in standard form with the squared term having a positive coefficient. So what does this mean? What this means is if they don't give it to you right out the gate looking like this, you need to make it look like that. You need to just have it in standard form, meaning in decreasing order, starting with x squared, and there can't be a negative in the front. And we're going to do one when there is a negative in the front. How we take care of it. Okay? So the first step is to get it in the right form. The second step is to factor the side that's not 0. So factor the trinomial or binomial. Third, set each factor containing a variable equal to 0 and solve it. And the last step is to check your solution in the equation. Now I'm going to keep this up here and we'll just refer to it as we'll work at some problems. Okay, first problem. 9x squared equals 27x. I have to first write that equation in standard form with the square first and not equaling 0. So what this means is I just want all of the stuff on one side and the right side to be 0. So I have to bring 27x over to this side. That's my first step, is to put it in standard form. Now this time there's not a plus c. Is that a problem? It's not. As long as I have a square, it's still a quadratic equation. Second step, factor it.
What was or not? I missed that.
As long as there's a second term, a degree 2, it's a quadratic equation.
No.
The x squared is a 27.
No, I know. As long as there's not a plus what?
C.
Oh, a plus c.
Oh,
Like in the
okay.
form
Just
ax
a
squared
number.
plus
Yeah.
bx plus c. You don't have to have these two terms. You have to have that term for it to be a quadratic. Okay?
Yeah, I understand it. I just didn't hear what you said.
Yeah, it's okay. Sometimes I don't know what I said either. Okay, second step, I have to factor. How do I factor this? Oh, I can take out more than that.
Take out
9 and a what?
X.
Take out a 9x, and I'm left with x minus 3. Still equaling 0. I factored it completely, so what's my next step? It's set each factor that contains a variable equal to 0. 9x is a factor. I'm setting it equal to 0. X minus 3 is a factor. I'm setting it equal to 0. So your factors don't have to be in the parentheses. They're just two different terms I'm setting equal to 0. Everybody okay with that? Okay, so now I need to solve for x. I divide both sides by 9, and x is just 0. I add 3 to both sides, and x is 3. So I've solved this equation for x equals 0 or x equals 3. My last step is to check. I'm going to put it up here and see if it makes sense. If I put a 0 in here, is that true? Yes. If I put a 3 in here, is it true? Yes.
X equals 0, I don't understand that.
Okay. Do you understand why 9x is equal to 0?
Yes.
Okay. All I'm doing is solving for x. So I'm dividing both sides by 9. And x equals 0. Good?
You could put 0 over 9 to do that with
Mm-hmm. Technically, yeah. Okay, next problem.
Actually, do you want to like graph these on
Yes,
Is it
that's,
plus thing?
that's an 099. You're going to graph parabolas. I don't think we do it in this course. Let me look. Ooh, I might be wrong. Maybe it
No.
linear equations.
Seven.
No, I think that's 099. Or do we do it in 7?
Graphing linear equations.
That's just linear equations. We're not going to get to graphing quadratics. Okay, guys, this is my next problem. Step 1, is it in standard form?
No.
Okay, what do I have to do, Emily?
Take that 4 and replace it for.
Yes, I want the right side to be 0. So before I start the problem, I'm taking 4 over here. Very good. Now, because you're not dividing it, you're subtracting it from it. So what you're really doing is subtracting it to this equation, and then these are the only like terms. Okay. You would take it to every term if you like. Make sense? Okay. So now I have standard form equals 0. I can factor. Can you factor this? X what multiplies to give me
5 and 6.
30, adds to give me 11, and it is 5 and 6. So I have x plus 5 and x plus 6 equaling 0. Everybody good so far?
So at this point, you can just assume a 10,000.
Yeah, at this point, your answer is -5, -6. But in the interest of working through the problem,
Yeah,
then
understand.
we're gonna,
But it's always like those two places.
when there's no number here, say yes. But on your work, you would want to show that you're setting each term equal to 0.
So we would have to show our work even if we know it?
Yes. And this is -5, and this is -6. The last step would be to plug it back in your original equation and make sure it holds true. Okay, very good. Okay, first
Wait,
step.
wait, how can that be right? I'm sorry. Okay, negative x squared would be a positive 25, right?
Okay, so you want me to plug them in. Let's
Yeah.
plug -5 in. -5 squared plus 11 times -5 plus 30 has to be 0. 25 minus 55 plus 30 equals 0. -55 plus 55 is 0.
Okay.
Good?
Yeah,
I know
I
sometimes
was
don't
actually-
trip yourself up in the checking.
I was
because
actually going up to the original equation, and that's why I got confused.
it would just have to be 4, but it should still work.
So the same answers would work in that one as well as,
So instead of 30, all you would have had to do here is say plus 34 equals 4. Plus 34 equals 4. And that is -30 plus 34 does equal 4.
okay.
Okay? So it doesn't matter which one you use. It should still equal out when you check your answer.
Okay.
Okay? Okay, this equation, we first have to write it in standard form equaling 0. So what do I have to move? The 10z. How do I move 10z? I have to add it. I'm not dividing. Be careful, because this is a subtraction sign. I add it to get rid of it. And I add it to its like term. So now I have 5z squared plus 20z minus 60 equals 0. What is my first step of factoring? Take out the 5, take out a 5, the GCF. If I take a 5 out, I have z squared plus 4z minus 12 equals 0.
Keep the same answer if you do that and you just go straight to
You would, but you'd have to end
So
up
it
taking
takes-
the 5 out at the end because it will be completely factored.
It's like then you end up with -300 plus 1. But you can still factor.
You can still factor, but then when you find your factors, you'll see that you have to take another 5 out. So it either has to happen at the beginning or at the end. Okay. Here we need two things that multiply to give us -12 and add to give us 4. Positive 2 and the -6. No, I think that should be the other way around. Right? Positive 6 and a -2. That looks better. Okay, this is a good example because the next step is to set each factor containing a variable equal to 0. So do I set the 5 equal to 0?
No.
No, it doesn't have a variable. There's nothing to solve. As a matter of fact, if I divided 5, what happens to it?
It's 0.
It just disappears. It's 0. So that's why you're only taking terms with a variable and setting those equal to 0. So z is going to be 2 or -6. And then I want to check. So you understand when there's a coefficient out front, right? And I guess it wouldn't hurt to say 5 equals 0, but it's not going to reach anywhere, right? It's not going to get an answer.
That 5 doesn't use.
Here's another clue for solutions. Whatever degree term your equation is how many answers you should have. So because we're doing quadratics, degree what? 2. How many answers should I get? 2. When you do trinomials in 099, you will get 3 answers because there will be 3 degrees. 4 would be 4 and so on.
Are they gonna ask you if you have 2 answers on the bottom? It was like x plus 5, x plus 6, and the answer was
It's always the opposite.
yes. And you said, no, it's not always the opposite. But is that only if there's a number, like instead of z minus 2, it said 7z minus 2,
Exactly.
and then it wouldn't be the answer?
Correct.
Okay. Any other time though, it's just,
If it's just z minus 2, if there's just a variable and a number, then yes, it will be the opposite sign. I just don't want you in the habit of thinking that because when there is a number up front, you might tend to say, like if it was 7z minus 2, you might automatically say plus 2.
what is it? What is that?
You said it equal to 0,
Oh yeah, you do it, never mind.
and
Okay.
z would be 2 sevens. Okay? So it's better to think in terms of I'm setting this equal to 0 and solving than just looking for the trick of always the negative sign. Because that might end up messing you up later as you have that talk. So you're right in that, yes, it would be, but still go through the motions. All right, next problem. Okay, is this in standard form?
No.
Yes.
Yes, it's in standard form, but what else does it say over there? It has to have a positive coefficient in the front, and it doesn't. I can't start when there's a negative up front.
So you just pull the negative 1 out so that's fine?
You pull the negative 1 out, therefore changing the signs of everything inside. That's the important part. If I take this negative out, it changes these signs. What happens to my negative 1? If I divide it, where does it go? It just drops out. It goes into oblivion. Okay? So, when you see something like this, you can just think, I change my signs, and that's it. You just have to change all your signs. So now the problem I have is x squared minus x minus 6 equals 0. When I factor this, I get x minus 3 and an x plus 2. So as Melissa would say, the answer is just going to be the opposite sign. But to show your work, you would say x minus 3 is 0, x plus 2 equals 0. So x is either 3 or negative 2. So the only reason we went through this problem is to show you how to handle a negative. All right. Here's a common error on a test. Don't confuse factoring with solving an equation. When you see this and there's no equal sign, all you're meant to do is factor it. When you see the equal sign 0, you're meant to solve it. Very many times on a test, I will give this, and I will see people say, and then they'll do this and say my answer is negative 2 and negative 1. That's wrong. Okay? When it's nothing set equal to 0, your answer is just a factor. When it's set equal to 0, you should get 2 answers for x. So just make sure you're looking for that. Okay. Next. What do I have to do first? I have to get 0 on the right side, so I'm going to bring the 81 over here. Now when I go to factor this, what does that look like?
Difference squared.
The difference of 2 squares. This is x squared minus 9 squared. So my secret equation tells me it's a plus b, a minus b equal to 0. So x plus 9 is 0, or x minus 9 is 0. X is negative 9 or positive 9. This is a good one. Okay, so what are some thoughts of how to start this problem? What? I have to FOIL it first. Why? Good. If I bring an 8 over this side, where do I put it? It's just going to be at the end, minus 8. So that's not in standard form. So just because it's already starting in parentheses doesn't mean it's the factors. So what you need to do first is FOIL this out. X squared plus 2x minus 5x minus 10. And then I'm going to go ahead and say minus 8 equals 0. I brought my 8 to the other side. Hopefully they didn't confuse anybody because I did it one step. Now when I combine like terms, this is what I have. Now it's in standard form equal to 0. Okay, so make sure just because you see parentheses, you don't go setting these equal to 0, because there's a number over there. Okay, so I'm going to factor. What factors to be negative 18 adds to be negative 3? Negative 6 and a plus 3. Does that work? Okay, so x minus 6 is 0. X plus 3 is 0. X is going to be 6 or negative 3. And I can check that for the minute. All right, good. That was it for 5-6. Not too bad. So 5-7 is just using this knowledge to solve real-world problems, applying this to applications. And that is to answer the question you guys said last time, when am I ever going to use this? Somebody say something. Okay, so 5.7 are applications of quadratic equations. Applications of quadratic equations. Okay, here's our first one. It's a number problem. And it says the product of two numbers is 64. What does product mean? Find the two numbers if one number is 12 more than the other. So we've done these before. If one number is 12 more than the other, so the small number is x, the larger number is x plus 12. Okay? The product of these two is 64. So how do I set that up? Very good. Okay, so now what they want me to do is find x. So in order to find x, I have to distribute and get this in standard form. It's a quadratic equation, so the way to solve it is going to be with factoring. I've set it equal to 0. Now when I factor, I have to find two things that multiply to give me negative 64 and add to give me 12. So 8 and 8 won't work. And 4. 16 times 4 is 64, and if you do 16 minus 4, you get 12. So 16 and a -4 should work for both. And you just have to run through the factors until you come up with those numbers. Okay, so now I have x plus 16 and x minus 4 equals 0. And we continue it over here. So x plus 16 is 0, or x minus 4 is 0. So x can either be -16 or 4. Have I solved my problem?
No, that is larger number.
Now what is x in this problem?
The smaller number.
It's the small number. So this is the small number, or this is the small number.
16 is the small.
If -16 was the small number, what would be the large number?
-4.
-4. If 4 was the small number, what would be the large number? 16. So there are two answers. The two answers to this problem are -16, -4, or 4 and 16.
Would it be -16, 4? Or -4, 16?
This would be small, large, small,
Okay. Yeah.
large. There's two pairs of answers. What I don't want you to confuse is because you have two answers, it is not just -16, 4, because x is just the small number. It's not the answer to the large. So you're going to have two choices for answers. It could be this small large or this small large. Okay? Anybody have questions on that? That is kind of confusing.
This is fun.
So the reason why it's that is because there isn't enough information to really zero in on the number with what they've given
Well,
us.
based on the parameters they've given us, either pair would work.
Okay.
Because it just says the product is 64 and one number is 12 larger than the other. So sometimes there's more than one answer. Because this would work for either pair. Okay. So just remember when we're doing word problems or application problems with quadratics, the same thing holds true. If you have a degree of 2, you should have 2 answers. Okay, the next one is a geometry problem, and I have written, it's on page 325 is the picture. Let me see, it's just a rectangle, you may not know.
It is.
It is? Just a rectangle. Okay, don't worry about it. A rectangle, and its width, I think what it tells you is its length is 3 more than the width. So if this is the width, what is the length? If it's 3 more. Yeah, it's the width plus 3. So we have width and we have width plus 3. We need to find the area. What are the possible widths?
No, it says
I didn't
find
read.
the length and width if the of the sign if the area is to be 54 square feet.
Okay, there you go. I was looking for what it gave me. Yeah, it's example 2. Okay, so if the area is going to be 54 square feet, that's our given. We need to find what the width and the length would be. What's the formula for area of a rectangle?
Length times width.
The length times the width. In my problem, what is length? W plus 3. What is the width? W. And the area, they told me, was 54. Does that make sense to everybody so far? So when I distribute the W, I get W squared plus 3W. This is a quadratic, so I want to get 0 on one side. So I'm going to bring 54 over and set it equal to 0. I'm kind of switching the order because I wanted 0 on the right side. Now I'm going to factor. There's no GCF, So I'm looking for two things that multiply to give me negative 54 and add to give me 3. How about 9 and 6? 9 and negative 6? That works,
Yeah,
right?
positive 9, yeah.
Positive 9, negative 6 equals 0. So W plus 9 is 0, or W minus 6 is 0. So I can have a width of negative 9 or positive 6. Now with geometry problems, can you measure something as negative 9? You can't have a negative 9 width. So you can eliminate that answer because it doesn't make sense. So your only answer in this problem is 6. So they want to know what the width and length are. Width is 6 feet. Length is what? 9 feet. Very good. So you did get 2 answers because it's quadratic, but we've eliminated one because you can't have a negative 9. That will happen a lot with the geometry problems. A lot of times you'll get a negative answer and it won't work. Okay, next. Example 3 on page 326. This one says, in Earth's gravitational field, the distance d in feet that an object falls in t seconds after it's been released is given by this formula. D equals 16t squared. So all you really need to know is I'm giving you this formula. While at the top of the roller coaster, the rider's eyeglasses slide off his head and fall out of the cart. How long does it take the eyeglass to reach the ground of 64 feet below? So the 64 feet below is what part of this formula? D, the distance it fell, right? Because he's up here on the roller coaster, he loses his sunglasses, and they fall down. Okay? So they fell down 64 feet. So it's looking for how long, meaning t. So we're going to say in 64 feet, how long does that take? I just have to find t. Because it's a quadratic, I have to use what we learned today. I have to bring 64 to the other side. Then I have to factor.
It's showing it, you take the 16 over to the other side. Do you want to solve for t and then do this again?
Yeah. That's okay.
So now it's like.
Oh, I see. Yeah. Okay. They didn't. Well, I don't.
Then you put it to 0 when you find what t is.
It doesn't matter, does it?
Yeah, I don't like their list.
No, because it's,
I like it. Both sided. I want to do both sides.
Yeah, so we can check the divided 16.
Yeah. Okay.
And that's just
Let's try it the way we just learned first. And if it doesn't work, then I'll leave.
Okay, so 0 equals 16t squared minus 64. What do I do first to factor this? Take out a GCF. What's the GCF? It's a difference of squares, but first we have to take out the GCF. You can take out 16, or you could just do the difference like it is. But let's take out 16. T squared minus 4. Okay. So 16 stays here. I'm factoring this. It's the difference of squares. So I have t plus what? 2. 2t minus 2. What happens to my 16?
goes with.
I'm only setting factors with variables equal to 0. So t plus 2 is 0, t minus 2 is 0. So t is negative 2 or 2.
It works.
In this problem, what are we looking for? What is t? T is time. Can I have negative time?
No.
No. So what is my answer?
2.
2 what?
Squares.
Seconds.
Seconds.
Seconds. Because it's time. And in the problem, it told you that this formula is t seconds after it's released, so that's how you know you're doing it.
Yeah, I won't do it that way, okay?
No, yeah, that's the
I'm
way
not
they showed it.
ready
I don't know why they did
mentally
that.
to do it that way.
I don't know why they did it that way.
It's like, oh, you think you know that? Try this. You're like, no.
Well, what they're doing, really, is what we did here. They're taking out a 16. So it's the same as pulling up the GCF dividing by 16.
Yeah, they just divided first.
I don't lie. No.
But in an effort to be consistent with what we've learned, that's the way I should.
Did I
Okay?
do the sunglasses back?
Nope. They broke. If they fell
They did break.
64 feet. Okay, next problem. The Pythagorean theorem. Who's heard of the Pythagorean theorem before? Okay. What is it? Very good. Pythagorean theorem. Pythagoras. An old Greek guy. Okay, this, that's not very good. I don't like that triangle. Hold on. This little square in a corner denotes 90 degrees or a right angle. Whenever you see that square, it is giving you that information. It's telling you it's a right triangle. Pythagorean theorem only works for right triangles. Okay, so you have to know it's a right triangle to start with. C is what we call the hypotenuse. And A and B are just legs. Okay? The hypotenuse is always across from the 90-degree angle. The formula goes like this. A squared plus B squared equals C squared. Does it matter which leg you write first? It does not. As long as you're adding the two legs squared together and setting it equal to the hypotenuse squared, it will work. So A squared plus B squared is C squared. So one problem you might be given using this information is they will give you some sides of a triangle and ask you, is it a right triangle? So the first problem says, if I give you 6 inches, 8 inches, and 10 inches, oops, I said 10, but I wrote 8, is this a right triangle?
Yes.
Let's go about doing it, guys. So what can I assume are the legs? They're all, the hypotenuse will always be the biggest. Okay? So 6 squared plus 8 squared, does it equal 10 squared? 36 plus 64, does that equal 100? Yes, it does. So what do you say? Yes, it is a right triangle. Okay, next problem. 4 inches, 10 inches, and 14 inches. What is my hypotenuse in that problem? 14. So 4 squared plus 10 squared is equal to 14 squared. 16 plus 100, does it equal 196? 116. So, no, this is not a right triangle.
I have a question like this one.
Probably. I don't look at it yet. I'll print it out before we did. And then I'll know. I'm sure it will be in your homework. Okay, here's another kind of problem you might have with the right triangles. One leg of a right triangle is 14 feet longer than the other. The hypotenuse is 26 feet. Find the length of the legs. Okay, so this is good to draw a visual. They told us it's a right triangle. They told us the hypotenuse is 26. And it says one leg is 14 more than the other. Very good. So this is our setup. How are we going to go about finding what the legs are? We're going to use the Pythagorean theorem. So we're going to say x squared plus x plus 14 squared equals 26 squared. A squared plus b squared is c squared. I'll give you a second to catch up. That's a lot of writing.
They probably can't have a sum of two squares.
There's no special formula for the sum of two squares, but we know how to square a binomial. And what you're thinking of is factoring the difference of two squares. Right? Okay, so what she said is true. You can't just square x plus 14. Do not put x squared plus 14 squared. Wrong. Why? Because if you FOIL this, x plus 14, you're going to have middle terms. You're going to have x squared plus 14x plus 14x plus what's 14 and 14? 196. Okay? So there is going to be a middle term of 28x. Now if you'll recall, the way you do these is you square the first term and you take 2 times a and b, which would be 28x. And you square the last term. That's the same thing I got when I FOILed it through. So if you want to go off to the side and FOIL it, that's fine. If you remember the shortcut of squaring, doubling, squaring, then you got it. And it equals 26 squared, which is 676. Okay. We're going to combine like terms. 2x squared plus 28x plus 196 equals 676. But to solve a quadratic, what do I have to have it look like? I have to have it equal 0. So I'm going to have 2x squared plus 28x and take the 676 to the other side, and I get a negative 480 equals 0. Now I can factor this, but I can take out a GCF first. What would the GCF be? 2x squared plus 14x minus 240 equals 0. Then I want to factor this trinomial. I'm looking for something that multiplies to be negative 240, adds to be 14. How about 24 and 10? Sure. Okay. X plus 24, x minus 10. Only the factors with the variable get set equal to 0. So x is going to be negative 24 or 10.
So it's 10.
Because we're talking about a triangle, we can't have negatives. Do I stop here?
No.
No, I've got to go answer my problem. All I know is x is 10. So I know this leg is 10 feet, well, 32 units, and this one is 24 feet. Okay, the answer is 10 feet and 10 foot. Okay, I only have one more for you. Do you see why factoring is useful now?
Yeah. Just to start measuring the outside. I think from that.
Okay. The diagonal of a picture frame is 13 inches. Let's draw us a picture frame. What can we say about a picture frame? It's typically square, right? It's a square frame. Or I mean, it could be rectangular. I'm saying the corners would be flush. It would be squares. They would be 90 degrees. Yes.
I don't mean to be smart, but if you had a picture frame, would you just measure it?
Yes, you can.
Okay.
But if you're a framer, say in Michael's, okay, and you needed to know the dimensions of what something has to be, given a picture somebody brings in, you have to know what the dimensions would be. Nowadays, they probably have a computer program where you just plug in what the sides are and it tells you.
They have an app for that.
Before they had an app for that, or a program for that, people had to actually do this and figure these things out. The people that made these computer programs had to know how to do this to make it. What? Yes? I know. Okay.
It's a test for online.
Yeah, there you go.
All right, so what else do we know? The length of the frame is 7 greater than the width. So if this is width, what is length?
Width plus 7.
Plus 7. Very good. Find the dimensions. Okay. We know that this diagonal will be our hypotenuse because it's across from the right angle. So this is our, does it tell us?
13.
Oh, it is 13. I was like, I hope it told me. So now to solve this problem, I have to use the Pythagorean theorem. W squared plus W plus 7 squared equals 13 squared. A squared plus B squared is C squared. How do I square this binomial?
3 squared plus 14.
Square the first term, double these two to make it 14, and square the last term. Very good. Or you could take it off to the side and pull it over. 2w squared plus 14w. I'm going to go ahead and bring my 169 over here. It's negative 120. What's my GCF? 2. 2. Okay, I am going to factor two things that are negative 60 and 7.
12 and
12 and 5, good. Plus 12 and a minus 5. That's another way of doing positive 7. This is equal to 0 and the 2 is still here. But I'm not going to set the 2 equal to 0. I'm just going to set my two factors with variables equal to 0. So W is negative 12 or 5. Because it's a picture frame, it can't be negative. So my width is 5 inches. And my length is 12 inches.
All right.
Very good. Questions about any of this stuff, guys? All right.
To the math lab.
Yes, please go to the math lab if you're confused on any of this. Our review day is Tuesday. We'll be taking another quiz, reviewing the quiz we did today, and going over what may or may not be on the test, answering any questions, okay? Please, over the weekend, do your homework, be caught up so you're ready for the review. All right, have a good weekend. Bye-bye.
I work all weekend.
That's not me.
I need groceries.
You buy mine?
Pardon?
I said, want to go buy mine?
Yeah, Sam's Club.
That's actually where I'm going today too.
Yeah.
I have to bring 20-something potatoes to a baby shower. They're doing a potato salad bar, so
That'd be like $5 for a giant bag. I love Sam's Club bag stuff.
not so good on cereal, but I like it. I don't go to too many baby showers. But one of my friends had a oops over 40 baby. Oh, yeah.
I'm worried. I got my tubes tied because my last one was an oops. I'm birth control. We don't anymore. So I got my tubes tied. Then our neighbor's husband was 10 years after his mother died.
Oh my. They're all a blessing.
I'd love to have another one.
I would too.
It's not gonna happen.
Not yet. Have you been married long? 3 years. Oh, that's good.
Yeah, but we
our
biological
first
clock
one
was
was
ticking.
together within the first year. So we were only together for 4 years. And then he got deployed. Yeah. Well, I'm sure you have time.